Good afternoon. Good afternoon, everyone. I couldn't have asked for a better lead into my session than two data leaders candidly talking about how hard it is for them to push some of these agents and AI work into production. So everybody is building agents, right? So, but in my observation, very few teams are able to successfully take these agents from a development environment all the way into the production. Because while we are developing, we almost always optimize for capabilities. But when you want to run something in production, you have to optimize both for capabilities as well as trust. Now, that is the precise gap that we are trying to solve using AI observability. So, AI systems, they don't run in isolation. A typical AI system has access to your documents, to your APIs, to your databases at some time, your sensitive information, your code, and PI information. Now, when something goes wrong, the failures are subtle, invisible, and operationally risky. Now, this is the trust problems that enterprises typically see and sense and are scared of when they want to reliably run an AI system in production. So let's lead in with a small example. So now we are going to talk about an AI chatbot that is built for a bank. Now it's a fairly friendly chatbot that is designed to help customers answer questions about their loan eligibilities, their financial transactions, and what is the overall status and health of their account. Now, when this AI agent starts operating, when a user interacts with this AI agent, the agents have access to the PI information, financial information. It has access to various tools that in turn have access to your queries, databases, and a small mistake on the part of the agent is no longer a mistake. It's a production issue. So you don't want to be showing incorrect information about some sensitive data like your financial transactions incorrectly to your user. So any small mistake that happens on any of these agents' part in their decision making or in their tool calling, or when these agents are dynamically making these decisions, are no longer small errors or issues or bugs. They are straight classified as production issues. Right? That is the kind of problem that AI agents brings into enterprises. Now, let me quickly dive into a demo. So this is a friendly chatbot app that I created to showcase our AI observability product. So this is like any other bank homepage that you would see. So there is a user called Sarah Michael. So she has some healthy savings in her account. Good to her. Now, on the top right, you see a small chatbot, chat with AI, right? Let's click on that and let's fire up some questions. So the first, I have seeded some questions in the interest of time. So first question she asks is about, am I ready to buy a home? Now the chatbot is accessing its, calling its tools, running some workflows, doing some analysis, and it gave a pretty good answer. So you have a strong income, a very solid credit score, healthy savings, low debt, so on and so forth. So the home purchase readiness assessments, the next steps it says, okay, redirect the Robinhood transfers to your savings account, get a fully pre-approved loan, pay down your debt, blah, blah, blah. So it's kind of helping you make a financial decision. Now, I've asked another question. Why was my credit card or debit card declined? So the bot talks about, okay, not having access to the logs, but it clearly shows how much account balance you have and the next step that you should do. So on the face of it, it looks pretty good, very helpful, and something that all of us would like to see from an AI bot answering in specifics. Now, when I ask about monthly spendings, it gives a very detailed breakdown of the rent, the investment, the health, groceries, lifestyle. And if you go one line below, It gives you very specific details about where Sarah lives and the kind of money transfers that she does into Robinhood and the kind of other expenses that she does over a period of last month. Now, this is all good. Now, let me quickly switch back to our AI Observability product. So you can access, starting from today, the AI Observability product on the left now, once it is enabled, on the bottom but one option. So when you go onto this AI Observability, I'll be showing various features and various functionalities that we are excited to show to you guys and we have developed over the past few months. So first thing that I would like to show is every AI system, as we all understand, it works on bunch of prompts. So these prompts are fed into your tools, and these prompts are actually the harnesses that will help you get a good answer from this LLM. Now, typically it's a good practice to have these LLM prompts committed somewhere in a GitHub or in a product like AIO. Now, you can always ask, okay, why should I commit in something like an AIO? Why not in GitHub? So I'll show you the advantages of using a system like AIO when you want to show your prompts. So this is the first prompt. I marked it as a production tag. So this is the prompt that my agent has picked while it was answering your questions. Now, quickly let me run through what are the other interesting things that AIO would show. So we have created projects, and before coming, I just created a project called Autonomous National Bank Prod. So when I go into this particular project, it shows the last few questions that I asked. So this is the monthly spend down. Now it will give you all the information around all the tool calls that are made. So the banking agent called another banking agent, a lookup for the profile has happened, some transactions are fetched, and a summary of the advice has been generated. And it also shows the model that got used, which is Bedrock. And on the right side, if you notice, the entire trace of the entire user interaction is available. So on the right top, you would see the question that has been asked. The customer ID, the model ID, those are custom parameters that you would like, that you can pass if you wish, and the final output the way it is shown up. Now, this is pretty good, but if you subtly notice this, this is not super acceptable, or this might not be very comfortable in certain scenarios for certain organizations. It has quite a good amount of information. It talks about the hospital that Sarah visits, the place where she buys her medicines, and when you look at it, it directly takes the credit card numbers without any masking, and it kind of emits out the credit card numbers out. Now, this is not just with the bot, right? Now, all this information has traveled all the way from your database to an agent, to the LLM, and back, right? Now, there is a lot of chain of data that got created, and all this data is stored everywhere, wherever we are trying to trace this data. So this is where the traditional observability system comes in. So a traditional observability systems are generally designed to trace, monitor, and debug whatever are the user's interactions that are happening with a LLM, foundational LLM models. But they don't help you govern, redact, block, or detect data leakages, and they don't give you a comprehensive framework for governing your LLM interactions with your users. So that is something that we want to present proudly here. So let me go back to our app again. Now this time around, I'll go to the prompt, and let me go to the other commit. So I have preloaded with another commit, which has a prompt which is slightly better improved than my first prompt. So I see all the traces in the trace panel. I can select few of the traces, and I can annotate them. I can mark them for offline evaluation. I can evaluate them, then look at what kind of a data leak and data breach is happening, try to work on my prompt, improve my prompt, and put in a new prompt over here. Now, what I'll quickly do is I'm trying to promote this particular prompt into production. So I'll remove the production tag from there. And I'll quickly add 2 new tags. So I've added 2 new tags here, which you can see in the bottom left. One is called PIA check, and other one is called production. So what does it do? So these 2 tags I have put in my code for this banking app such a way that when I see these tags, or I'll pick the tag, or I'll pick the prompt that has the tag called production, and I have also made provisions in the code that whenever I see PIA checks, I'll enable certain checks on the particular LLM interaction. Now, let's go and see what are those checks. So those checks are available in the online evaluation. So you would see that I have added quite a few checks that every interaction should pass for us to coin it as a good interaction with LLM. The first check is disclaimer present? Did we give an unlicensed financial advice? Did we disclose any merchant information? Did we reveal any PI information, any health information, or PI account information? Now, let's take a step back and see how this works. So when you configure something on the control plane of AI observability, now all you need to do is integrate with our SDK, and most of the rules that you write, or all the rules that you write here, are automatically pushed onto the, or are made available to the SDK. The SDK can pull in those rules periodically, or depending on when you want to release it. And these rules have to pass for us to sometimes even answer a question, or to rank a question saying that, okay, this question has been good, this question has been great, or this is some questions that are not falling in our benchmark. Now let's see how does that work. So I'll come back here, ask the exactly same question. Where is my money being spent? Okay, this time the answers are a bit different, and they reveal far lesser PI information. So it talks about housing, investing, groceries, discretionary, transport fees, no personally identifiable information has been exposed, or no personal details have been exposed here. And when I ask the second question, this is where things get even more interesting. So this is mostly reactive, right? So the prompt has gone, we generated the answer, and then we are controlling how the LLM should answer this question without revealing personal information. Now, in many cases, when the prompt, along with its tool information, makes its way into the LLM, the damage has already been done, right? If I redact here, nothing much is going to change. Now, in many cases, enterprise would love to have a feature wherein this prompt itself is stopped, and we don't take it forward anymore. Now, that is precisely what happens here when I give my credit card, when I enable my PI checks. So why was my card 411 declined? For security reasons, I can't process this message. This contains credit card number. Please rephrase without sharing any information. So these checks are completely customizable. They can be written industry-specific, domain-specific by your own engineers, and can be managed from a centralized platform like AAO, where we can use our SDKs, or the customers can use our SDKs to pull these runtime checks, similar to our DQ checks, to be performed on your LLM interactions before they even reach LLM. Now let's see. So let's see how that manifested here. So let me quickly give a okay. So while I was showing this screen the last time, I intentionally missed some of the columns, or I wanted to reveal it late in the cycle. So along with the traces, some of the run-of-the-mill items like what is the duration of the request, how many total tokens, what is the cost, these values are available all the time. But if you look at it, all the runtime checks that we have added, they start appearing as a column. Now, a value of 0 indicates that that particular rule didn't pass, and you have a request, and you have a request that is not passing your quality gates, and a value of 1 means that, okay, the request has passed your quality gate and it is as per your rules that you have configured. Now, something like this gives all the leaders who are trying to onboard LLMs into their AI agents and to make some of these agentic workflows possible, a fresh breath of confidence that it is not just a development game anymore. Even at the runtime, if I may have to control some of the behavioral aspects of these agents or behavioral aspects of how the data is getting exchanged between agents and our platform can be controlled. So this is how AIO would typically function. So user interacts with AI, and built into these agentic applications, we have an AO layer. This AO layer guards against a lot of these requests and tries to either validate, pass these requests or fail these requests depending on the kind of rules that users have configured. And it will guard from exposing sensitive data, internal tool information or financial systems information to the end users. Now, okay, so in my opinion, enterprise teams, they very well know how to run a complex system in production, but with the new AI paradigm, it generally increases their surface area of risk. Now you have multiple versions of LLM to be worried about, multiple versions of APIs to be worried about, multiple versions of prompts to be worried about, and user interactions to be worried about. And on top of it, all the generated decisions, how good are they, how are they doing according to whatever spec that we wanted them to perform, becomes even a bigger challenge. So the next generation of enterprise platforms will not just help you build AI systems. These platforms should also help you guard and trust the systems before putting into production. And that is the direction we are building forward in AIO. Thank you.